Welcome to this webinar. The idea behind what we're going to talk about today is to help you understand what it is that you can do with these two new open source tools called Flight Recorder and Mission Control. Now, these tools have been around for a while. We'll explain where they came from, what the background is, and so on. But it's only more recently that they've become part of the OpenJDK open source project. And what that's allowed us at Azul to do is to take the code and backport it so that people can use it with JDK 8 as well as with JDK 11. Now, what I'd like to do to begin with is to run a little poll of the people who are attending the webinar. And so I have a question which I'd like to ask you, which is how do you monitor your Java applications? I've given you 4 answers to this. First is that you use commercial application performance monitoring tools, things like New Relic, things like App Dynamics, things like those types of tools. And the second option is that you use open source tools, so things like Visual VM, those types of things. And the third option is that you use things that are built into the IDE. So IntelliJ has these kind of things, NetBeans has them, Eclipse has them, where you can monitor virtual machines with those. And the fourth option is, well, why do we need to monitor our JVM at all? Okay, so I've given people a few seconds. So if we click on the results, if we can show the results to see what people have said, then hopefully, yes, there we go. Right, so what we see is that about 15% of the people are using commercial tools. Interestingly, the majority of people here, over half of them, are using open source tools. And then we've got a few people, very few people who are using the IDE. And interestingly, nearly a quarter of people not quite sure why they want to monitor their JVM. So hopefully the rest of the presentation will explain what you can do and how it is that you can get interesting information from the JVM about what your application is actually doing. Right then, okay, so let's talk a little bit about the history of where Flight Recorder and Mission Control came from. Now, they've been around for quite a long time, and they were originally developed by the JRocket team. The JRocket team were a team that developed not just the Flight Recorder and Mission Control tools, but also a virtual machine. And this is what Oracle acquired through the BEA acquisition. And so they acquired all of this technology at the same time. And really the idea behind Flight Recorder and Mission Control was to help in the development of the JVM itself, because the developers need to understand, well, what is the JVM doing and where are the places where there might be issues in terms of performance? So they needed some kind of tool to look at that. What they discovered was that by doing that, they could also get a lot of information about how the application that was running on top of the JVM was also performing. Now, clearly, Oracle acquired Sun Microsystems back in 2010, and at that point, they rebranded Flight Recorder and Mission Control, and they literally just added the word Java in front of them. So we've got Java Flight Recorder, Java Mission Control. More recently, what Oracle have decided to do is to contribute this as open source to the OpenJDK project. Prior to OpenJDK 11, these were available in the Oracle JDK, but they were commercial features. And that meant you needed to switch them on explicitly. And if you wanted to use them for development and for testing, that was okay, they were free. But if you wanted to use them in production, then you would need a commercial license for that. Part of what Oracle have done more recently in terms of JDK 11 is to have convergence between the Oracle JDK and the OpenJDK. Half of that was removing certain features, things like the browser plugin, things like Java Web Start. But also what they've done is taken a lot of these commercial features, Flight Recorder, Mission Control, application class data sharing, and contributed them to the OpenJDK project. So now, functionally, there's no difference between what you would get as the Oracle JDK and what you get if you build the OpenJDK source code. Part of what they did with that is they also rebranded them because Oracle have the Java trademark and they're very protective of that. And they decided that rather than calling them Java Flight Recorder and Java Mission Control, we now start calling them JDK Flight Recorder and JDK Mission Control. So that's really the history of them. What we've done at Azul is, as I said, take the open source version in JDK 11 and backport it into JDK 8 so that you can still use them with the Zulu JDK that I'll talk about at the end, and use those on a JDK 8 application without any problems and without needing a commercial license. Now, if we look at what Flight Recorder and Mission Control actually are and what they do, I've put together this diagram to help you understand that. Essentially, Flight Recorder is a way of, as the name would suggest, recording or making available information about what is happening at a very low level within the JVM. And what it's also able to do is to give you information about other parts of the system. So you can look at what's happening in terms of the application. You can see what classes do you have loaded for your application, how many objects are being created by the application code. That obviously relates to things like how frequently the garbage collector runs. You can see what's happening in terms of the methods that you're using, which methods are being processed by the just-in-time compiler, the JIT compiler, how long compilation of that code is taking, when that code is no longer being required and when it actually gets flushed from the cache, those types of things. Obviously, there's lots of information about what's happening in the JVM from the point of view of the memory management system, how objects are allocated, when garbage collection runs, how threads are being managed. So you can also get a lot of information about the state of the individual threads in both the application and the JVM itself. You can see whether they're running, whether they're sleeping, whether they're ready to run, all of those types of things. And then you can even get information at a sort of superficial level about the operating system. And you can see which version of the operating system you're using, what environment parameters are being set, things like that. The information that the Flight Recorder gathers can be handled in one of two ways. Now, if you want to, you can create a recording of that and write it to disk. So you can create a file which contains all of the information. Alternatively, you can take that information in effectively real time as the application is running, as the JVM is doing its work, and you can feed that into Mission Control. And Mission Control, as you can see, can either take the live data from Flight Recorder or it can read the information from a previous recording. What Mission Control is all about is allowing you to take that information and create a visual representation so that you can see exactly what's going on. And I'll do a demonstration of Mission Control a little bit later on so you can see the types of things that you can do. So Mission Control is all about saying, okay, let's take that information and make it usable in a way that people can look at it, and rather than having to process lots and lots of individual pieces of data and lots of numbers and things like that, it's about saying, okay, show me a picture which shows here's how the usage of the heap grew over time, here's the threads that were active at a particular time, what state were they in. All of those things I'll show you as we go through the demonstration. So clearly, as you can see, we have the ability to either use Flight Recorder as the application is running, or we can create a recording and then process it later. So let's talk a little bit more detail about Flight Recorder and what it does and how it works. So the first thing is the basics of Flight Recorder. And what Flight Recorder is all about, is, as I've already explained to some degree, is profiling an event collection. And it's about getting the information that's right at the low level of the JVM. A lot of tools interface with the JVM through the Java management extensions, and they're able to get certain pieces of information. But Flight Recorder, because it's built into the JVM, is able to use the very low level information that is actually gathered by the JVM itself in order to do its own work. So really, we're just leveraging the collection of data that is already happening within the JVM to make that information available externally. That's very important because it enables us to do a certain number of things. One of the things that often is a problem with having tools that analyze how an application is working is you get what's called the observability effect. And to use my very early background, I did physics at university, and you probably know there's a thing called the Heisenberg's uncertainty principle. Heisenberg's uncertainty principle says the act of observing something changes what you're observing. Now, that's really talking about quantum mechanics and when you observe very small particles, but it also actually applies to computer software. What can happen is that in order to gather information about what's happening in an application, you have to instrument it. And instrumentation is where you add extra pieces of code that enable you to get events and get information about what is happening. Good example of that is if you wanted to instrument your code, you could say, okay, every time I enter a method, I'm going to send a message to say that I've entered that method. Every time I leave a method, I'm going to send a message to say that I've left that method. By collecting that and looking at the timestamps associated with that, you could see how long you were in a method. But the problem with that is that you've got overhead in the sense that you have to send a message from each entry and exit to a method. And what that can do is distort the way that the application actually works. That can be quite extreme in certain situations, and I've certainly been involved in things where what's happened is that by adding instrumentation and adding debug information to an application, you actually change the way it behaves so much that you lose the problem that you're trying to solve. That can be really frustrating at times, but what the idea behind Flight Recorder is not have that problem. So typically, the overhead that you will get associated with using Flight Recorder over not using Flight Recorder is less than 1%. Flight Recorder is very much designed to work with long-running applications. If you've got a short-lived application, then you may find that the overhead is a little bit higher because of the way that the warm-up works in the JVM and things like that. But if you're running a server application that runs for hours, days, weeks even, then very much you will find that the overhead will be less than 1%. The good thing about that is it means it's very much safe to run in a production environment. And you can have Flight Recorder available, you don't have to have it enabled all the time, but when you need the information, you think, okay, there's a performance issue with my application, I need to gather more information, you can actually go in dynamically, you can turn on the Flight Recorder recording side of things, you can dump information and gather the information that you need, but definitely working in a production environment. In terms of how we control the Flight Recorder, we have a number of command line flags that we can use when we start up the JVM. Now, by default, if you're using JDK 11 or if you're using Zulu JDK 8, then Flight Recorder will be on by default. So you don't actually have to do anything to make it available. If you don't want it there, then you can turn it off explicitly. You can use the -XX minus Flight Recorder flag, and that will turn it off. But assuming that you're going to use it, then you don't have to turn it on explicitly. What you can then do is you can set certain parameters using these two other flags, the Flight Recorder options flag and the start flight recording flag. What that allows you to do is to specify a set of option and value pairs separated by commas. Now, the way this works has changed a little bit. If you're used to using the Flight Recorder on JDK 8, the Oracle JDK 8, then you would only have used the Flight Recorder options flag. In JDK 11, for some reason, they've moved some of the options to the start flight recording flag, and so you need to figure out which ones you're actually going to use. For Zulu JDK 8, because we've backported from JDK 11, it will use the start flight recording flag rather than Flight Recorder options all the time. As an example here, I've shown how we can do that. So we start our application and we say start flight recording, and we can specify that we want to dump all of the information that's collected by the Flight Recorder when the application exits. And we also want to say where we want to put that information. So the file name is going to be in /tump dump.jfr, and then we run our application. When the application finishes, a file will be generated with all of the data that was collected by the Flight Recorder during the run of the application. And there's various other things that you can set using that. If you look at the documentation, you can find out all the various options that are available to you. Now, the way that recording of data works is that you can either do it in a continuous way or you can do it over a fixed time period. If we talk a little bit about continuous recordings, the way that this works is, again, in one of two ways. You can say, I want to just simply write all the data that's being generated straight to disk, so it writes it straight to a file. But obviously that file is going to increase over time, and if you're not really interested in necessarily all of the information that's being collected, what you can do is say, okay, I don't want to store everything out to disk. And what will happen is that the JVM will only keep information in a buffer in memory. What that does is it uses a global buffer, so all of the information goes into a single buffer, and it's circular in the way that it works, which means that when it fills up, the new data will start to overwrite the data at the beginning of the buffer, so it's circular and old data gets overwritten. The size by default actually seems quite small. It's only 462 kilobytes, but that still gives you the ability to write quite a lot of data. And if you want to, you can change the size of the global buffer size through the command line options and make that bigger if you want to. What you can then do is you can say at any point, if the application is doing a continuous recording, at any point you can say, give me a dump of the information that is in the buffer at the moment, or give me a dump of the information from the last 5 minutes, for example. And again, I'll give you a demonstration of that later on. In terms of the events that are recorded by the flight recorder, you can configure that at quite a fine granularity level as well. And there is a file which is called the default.jfc file. That is in the lib JFR directory, depending on whether you're using JDK 8 or JDK 11. That's slightly different in terms of where it is. For JDK 8, it'll be in Java Home JRE lib JFR. Because the JDK 11 doesn't have a separate JRE directory anymore, it's just in the Java Home lib JFR directory. If you look at that file, you find there are 131 different types of events that can be recorded. And there's configuration that you can specify with that. And again, you can do that through the mission control. You don't have to edit the file manually. You can if you want, but you can use mission control to do that through a graphical interface as well. Lots of different types of events. If you look at that, you'll find out all the different things that you can see. And so what that allows you to do is say, okay, I'm only interested in certain types of events, so let's turn off some of the other ones. That way we don't have to record information that we're not interested in. We can just record the particular things that we want to look at. Or you can just say, record everything and I'll have a look at what's going on. In terms of interacting with the flight recorder, you can use mission control. You can use the command line flags when you start the application, but you can also use JCommand to interact with the JVM from the command line directly. So whilst the application is running, you can change things. You don't have to do it through mission control. So if you want to do that, there are a certain number of arguments you can specify. What I've shown here is the sort of basic operations. There's more than this, but you can do things like JCommand, then you specify the application you're interested in, either by its name or by its process ID. And you can say, in this case, Java Flight Recorder start, and that will start recording the flight recorder data. What that will return to you is a name, which is essentially just a number that you can use in terms of being able to dump information, because you can actually run multiple recordings at the same time. So if you wanted to have different configurations, you can do that. You can also say, okay, start with default recording true, which means it will do continuous recording. If you want to grab information, as I said, you can generate a file directly. You can simply say dump name equals 1, which is the number that you would have got when you started the recording. And again, you say what the file name is, where you want to store the information that's being recorded by flight recorder. And then when you want to stop the recording, again, you can interact and you can say jfr.stop. So you have the ability to use command line, you have the ability to use mission control, you can use the flags when you start up the JVM. So it's very flexible in terms of how you can use flight recorder. Okay, so let's talk a little bit about mission control, because that's the other piece which enables you to process the information that's recorded by flight recorder and then start to get an idea of what's actually happening in your application. If we look at the basics of mission control, as I've already said, it's really a way of analyzing the data that's recorded by the flight recorder. What you have is essentially, to start off with, you have a browser for all the JVMs that you might want to interact with. That will pick up on any JVMs that are running on the machine that mission control is running on, but you can also connect to a remote JVM if you want to over a network connection. We'll talk about that in a moment. Essentially, the idea is that you can use the JMX console in order to interact with the JVMs. You can start recordings, you can stop recordings, you can set up continuous recordings, you can do dumps from a continuous recording. Many of the things we've already discussed can be done through the mission control interface in terms of deciding when and how you want to gather the data. If we look at a simple example of the JMX console, again, I'm going to show you the demonstration a little bit later on, so I won't talk about this in too much detail, but this shows how the browser works. And on the machine that I took this screenshot on, you can see that I had NetBeans running. Yes, I am still a NetBeans user. And then I have my application called loader.main running, and then I have mission control running. Mission control runs on top of a JVM, so obviously it picked itself up. From the point of view of the NetBeans, as you can see there, it says flight recorder last attempt failed. When I was running NetBeans, I thought to myself, oh, maybe I'll try and see if I can actually gather some information from NetBeans. But I hadn't realized that the version of the JDK that I was using was the Oracle JDK, and I hadn't turned on the commercial features. So flight recorder wasn't available by default. Because the loader.main application that I was running was on top of Zulu JDK, that had the flight recorder turned on by default, so there was no issue with that. Similarly, the mission control was running on top of the Zulu JDK, and so there was no issue with that. But what we can do is we can use that to, as I say, set up various things in terms of how we want to interact with those JVMs. We can connect to remote JVMs, we can turn things on, turn things off, and so on. In terms of remote connection, if you want to gather information from, let's say, something running on a server or something running in the cloud, then you do need to configure that JVM to enable mission control to interact with it. There are a couple of things you need to do. At the minimum, you need to configure a specific IP port that mission control can talk to on that IP address. In this case, I've used the default, which is 7091. Also, for the purposes of the demonstration that I'm going to show you, I turned off authentication and I turned off the use of SSL. I wouldn't recommend doing that in a production environment. If you're running in a production environment, you can use authentication, so you can set up the connection with a password and a username, and you can set up SSL connections as well. So these are things that you can do to simplify if you're running in a controlled environment. The other thing I found that if you're running on a Linux system, in order for this to work, the host file has to include the actual IP address of the machine that's running. The machine I've got here in my office has Ubuntu running on it, and when you look at the host file, the host name is given with a local host IP address. So you have to change that to the right IP address that you would normally connect to across the network, and then everything will work. What you get if you connect to a running JVM, you can do live monitoring. And again, I'll show you this on the demonstration. So this is really just a screenshot to give you an idea of what type of thing you're going to see. Obviously, the immediate information you can see is the sort of simplistic data about how much heap is being used, how much CPU is being used, and then you can get some information about the size of your live set and the fragmentation that's being observed within the heap. And then you'll also get a timeline here at the bottom where you can see how things are changing over time in the last sort of couple of minutes. And there's various other things that you can do with that. You can show different things, but again, we'll see that in the demonstration. Mission control rules. This is very useful. It's a very powerful feature, because often what you might want to do is to have a certain situation where you'd like to gather flight recorder data, but you don't want to be doing that continuously. You also don't want to do it on a timed basis. But what you want to do is have certain things trigger the recording of data. So a certain event happens that will start the recording of data, and then you can stop it so that you can analyze that data to see what happened in order to cause that. The kind of things that you can see here is the standard rules are things like when CPU usage goes above a certain level, then you can start recording, and that way you can sort of see, okay, we went above a certain level, what were all the threads doing? You know, was something happening that was unusual that caused lots of threads to be created, or threads were very heavily used, things like that. You can do situations where you've got deadlocked threads, so you can analyze that. You can look at the live data being, live set becoming too large, even the thread count becoming too high, things like that. Those are the standard rules, but you can also create your own rules as well. So if those ones don't quite fit what you're trying to do, then you can create your own rule that's specific to your situation. With a rule, you can then specify not just the conditions associated with that in terms of like what percentage of CPU utilization is going to trigger this recording, but you can also say what action you want to happen when that rule gets triggered. In terms of the things that can happen, obviously you can dump a flight recording, so you can look at the data afterwards, but you can also do things like sending somebody an email, you can send output to the console, things like that. So it's very flexible in terms of being able to configure what the rule does when something happens. The data that you get from mission control, because, as I said, there's 131 types of events that can be recorded by Flight Recorder. What you can do in terms of analyzing that is very comprehensive. So all the aspects that you would expect of the JVM behavior are being monitored. So you can see information about threads, you can see information about the memory usage in the garbage collector, lock instances, how the system is interacting through file I/O, socket I/O, all of those types of things. From the JVM internals point of view, you can see, again, detailed information about the garbage collection, a lot of information around the JIT compiler, because that's a large part of what the JVM does. Look at the code cache, what classes are loaded and things like that. And then, again, as I said, even from the operating system environment, you can see things like the environment variables, system properties, other processes that are running. So a very comprehensive set of information, which we'll see in the demonstration later on. Right, so quick summary of what we've talked about. The important thing here is what I've said in terms of what we do at Azul in terms of creating the Zulu JDK, and the Zulu mission control is related to that. So what Zulu JDK is that we take the source code of the OpenJDK and then we build that using the standard scripts into a binary distribution. Once we've done that, we run all of the TCK tests in order to verify that what we've created does conform to the Java SE specification. There's no reason to expect it not to, but to be absolutely sure, we run all the tests to make absolutely positive that we are complying with the standard. In terms of the versions that we support, we go all the way back to JDK 6. We have 7, 8, 9, 10, and 11 available, and we have wide platform support. We've got the normal 64-bit versions of Windows, Linux, and Mac on the standard Intel architecture. We've also got 32-bit versions of those for Windows and Linux, because we have some customers who are still running on older versions of the operating system and need a JDK that will work with that. And then we have ARM32, ARM64, PowerPC, and MIPS versions if you're looking to work on embedded applications. One thing I would say is at the moment, the embedded side of things, Zulu does not support mission control on Flight Recorder. It's only the Intel versions that do. From the point of view of Zulu mission control, as I say, what we've done is we've taken the open source version that was contributed to OpenJDK 11, and we've backported that so it works with the Zulu JDK 8. And what that also means is that when you're using mission control, it will work with any compatible JDK. Zulu JDK 8, Zulu JDK 11, the Oracle JDK 8 if you turn on the commercial features, and anything that's built on top of OpenJDK 11 will have support for Flight Recorder built into it. Just to sort of summarize again the Flight Recorder and mission control aspects, as I say, Flight Recorder is a very powerful way of collecting data, not just about the JVM, but how the application is working on top of that JVM. Because of its very tight integration at low level within the JVM, it's safe to use in production and doesn't have a significant impact on performance. As I said, less than 1% typically impact on performance. It's very flexible in terms of how you can use it. You can use it for mission control. You can set things on the command line. You can use JCommand if you don't want to use mission control, or if you want to do it through a command line. Another nice feature about this is if you're using an application that's been provided to you by an ISV, then you can say, oh, okay, something's maybe not working quite the way I want it to in terms of performance. You can use Flight Recorder, mission control. You can dump recording of how your application is working on your machine and what it's doing, and then you can send it to your ISV and say, here's the data. They can use mission control, they can look at it, analyze what's going on, and identify if there's something that needs to be done differently in terms of configuration to solve any performance problems in that way. Mission control, very comprehensive analysis tool for taking Flight Recorder data and then being able to look at what's going on, either in a running application or after the application stopped. And as I said, this is now available. Literally today, we've announced this as a download for Zulu JDK. Right, so let's look at a demo and see how this works in practice. So what I've got here is the mission control. Now, at the moment, what we can see on the left-hand side is the JVM browser. And the first thing that I'm going to do is actually connect to a machine that I've got running in my office, which is running an application that's doing some work. So if I create a new connection, and all I have to do is specify the IP address. I've got the port set up. As I said, when I started the application on my other machine, I set up the necessary JMX parameters so that I could connect to that. And hopefully if I test the connection, then it says status is okay. That's very reassuring. It's nice to see that my demo works. Doesn't always happen that way, but it's good to see that that works. So if we finish, what we'll see now is that we've got 10.0.0.1, and we've got the Flight Recorder there, which no recordings. Now, what I can do here is say, okay, let's start the JMX console, and that's going to connect to the Flight Recorder in that JVM across the network and give me the live information about what's happening on that machine. So hopefully, yes, there we go. We see that we get the same display that I showed on the slide earlier. And now what we're seeing is information about the Java heap usage, and you'll be able to see, depending on how quickly the things refresh, you'll be able to see that the memory is going up and down because I've set up the application to do a lot of object creation. Some of the objects are, the references are being maintained, a lot of them being thrown away, so that it makes the garbage collector do some work. Also, I've maxed out pretty much the CPU by doing a lot of maths and things like that, so that just to sort of make it look like it's doing something. The application itself is completely useless, doesn't really do anything useful. It's just designed to show how Flight Recorder can work. And then again, we've got information about flight set, live set, and fragmentation. And as we can see, we've got a little graph here that shows the usage. So we're seeing, in terms of memory, very typical garbage collection cycles where it's hitting a minor GC, reclaiming a lot of space from the young generation, which reduces heap usage, and then it gradually goes up again. So that's the kind of thing that we can see on a running system. I won't go into lots of the other tabs that you can look at because we'll look at those in terms of other things. But what I can also do is I can say, okay, let's create a recording of this machine doing some work. So if I select a recording, what I'm going to say is, rather than selecting a minute, because you don't want to sit here and watch me just have a minute's worth of data being recorded, let's record 10 seconds. So we'll record the last 10 seconds of the application, and then what we'll see here is that it's displaying how many seconds are remaining, it's recording the data, and after 10 seconds, it will save the data and it will open it up. Now, the first thing we do is we now switch to the outline. And the first thing at the top here is that we've got an automated analysis where the mission control tool is actually looking at all the data that's being collected and trying to identify if there are any obvious things that you might need to be aware of. And in this case, there's not a lot of things that are happening because it's a very simple application, but there's maybe some flight recorder settings that might, but we'll see some other things in this later on. But what we've also got is the ability to look at what's going on in our application. So we can see here, if I switch to this display, we've got all the threads that are happening in our application over that 10 seconds of data that's being recorded. If I pick one of those threads here, what I will see is this is my memory loader thread that I wrote, and I can also select a portion of time in there to zoom in on. And now what I can see is how that thread is actually working. And I can see that for some of the time it's asleep, so it's sleeping for 100 milliseconds. Excuse me. And then it does some work, and then it goes back to sleep for 100 milliseconds and does some more work and does that continually. If I look at another thread, that's not a very interesting one. Let's go back to the yes, yeah. So we've got all sorts of different threads, and we can see what things are happening here. So we've got that thread is doing some compilation. So it tells us that there's compilation going on. Funnily enough, in the compiler thread, you'd expect that. And all sorts of things happening there. Most of the threads are not doing anything terribly exciting. Again, if you want to look at memory, we can see that we've got the typical garbage collection cycles here, where the usage of the heap is going up, then dropping back down again as we do the garbage collection. The other thing that I would show on this one is socket IO, and so there's a connection here where we're sending a lot of port packets across the network. In this case, all that's happening is that the application is sending messages to mission control. So we're not really seeing any activity other than the data that's being sent to the mission control that's monitoring it. If we were using an application that was maybe a microservice architecture where you had connections to other services that were happening over a network connection, then you could analyze things here. You could see how much data was being moved around and things like that. So that's looking at that kind of information. If we go back to the browser, as I said, the virtual machine that's running the mission control is also able to collect data. And in this case, if we look at the flight recorder, that's running a continuous recording of mission control actually doing its work. What we can do there is we can actually say, okay, let's dump some recording data from that continuous recording. This is where we might have a situation where suddenly something changes in our application and an event happens. We go, oh, it'd be really useful to look at the last 5 minutes of data for this application. Let's grab that. So we'll grab that. And then again, what it's doing is it's saying, okay, take that data, do some analysis on it, and show us whether anything is happening. In this case, what we're seeing is that a lot of the physical free memory is being used. So my laptop's doing a lot of work, so we're using quite a lot of the physical memory. There's also some issues around socket reads. That's because of all the networking that we're doing, because of the fact that we're actually running a webinar at the same time. But it gives you an idea of being able to understand some of the issues there. What we can then do is we can look at things that might be a little bit more interesting. So let's say method profiling. So here what we're able to do is see what the top packages are that we're using, and then we can also see things like the top classes that we're using. And so we can see counts of certain things like that. So we've got all the different classes that are being used, and we've got stack traces that happen there. The next thing that's worth worth looking at is that we can also take a file that's been saved from another application. So rather than looking at running JVM and recording information that way, let's say somebody sent us a file for an application and we want to look at that. So in this case, what we can do is we can look at a flight recording that comes as part of the samples for JDK. This is Wildfly, and if we open that one up, it'll do the same thing. It'll analyze the data. It'll give us, hopefully, yes, there we go. It'll give us some information about what was happening with that application and do an automatic analysis. And so we see things like heap content is a bit high, stack depth setting, there's a lot going on there. But again, if we look into things like the memory here, we got a much more complex piece of data here, and we can say, oh, look, there's a sort of a very heavily used section here, and if we zoom in on that, we can look at information about that. We can see, okay, we've got things happening. We can look at stack traces that are associated with that, where we've got allocations and garbage collections happening, and it gives us that very high level of detail that we can dig into to find out what's going on in our application. If I open another one, the other file that I've got here, this is the Java 2D demo, and so that's got some interesting things in as well. What we can look at here is things like, if we look at, say, threads. Yeah, if we look at threads, yeah, we've got all sorts of information here about different threads and what they're doing, different status that they're in. So we've got threads that are asleep, threads that are running, threads that are waiting on monitors. We've got threads that are doing socket reads, so they may be blocked on that. So there's lots of information we can get from that. Also things like exceptions. So here we've got a situation where we're getting a number of exceptions. Interestingly, some no such method exceptions, no such field exceptions. If we look at an interrupted exception, as a simple example, we can see at this point from the stack trace that we were running animating surface, and then we went to sleep and we got an interrupted exception at that point. So again, lots of information, lots of detail about what's going on in terms of those types of things. If we look at some of the detail from the JVM perspective, we can see, okay, compilations, and this shows details about all the compilations that happened in terms of the different methods and how lots of things got compiled early on in this run. And we've got information about the different methods, how long it took to compile each one, what the code size was and things like that. And we can even dig into the code cache, which gives us very detailed information where, again, if we sort of highlight some of this and we zoom in on that, we can see activities such as where the code cache is being swept to see whether objects or methods are no longer required. We can see in this case that this method was reclaimed. We can see information here about methods being zombified, which is an interesting idea. So lots of information again about what's happening at the low level there. And even, class loading. There's information here about which classes are being unloaded, which classes are being loaded there. And we've got, again, stack traces here that we can go and we can see all the detail about how long it took to load classes, which classes are loaded, and so on. So as you can see, there's lots and lots of information available to you, and the ability to say, okay, I've got a performance issue with my application. What would I want to do? What information do I need to understand how to improve my application and how to work around these issues? So with that, what I'm going to do now is switch back to the situation here and look to see, because that's all I've got to talk about. So let's see if we've got some questions. Okay, so first question, I assume the lack of flight recorder or mission control in the ARM MIPS embedded spaces due to those constrained environments, tight memory and lower processing capability. That is part of it. I would say another part of it is simply the fact that we would need to port the necessary code into those versions of the JVM, and we just haven't done that yet. So I don't see there's any real reason why we can't do that. We just haven't actually done the work. It was easier to do it on the Intel side because for server class applications, that's really the sort of primary goal of this, rather than embedded applications. But who knows? We may actually get around to doing this at some point. Second question: does the visualization handle replay of data from a past time? That is, could there be several 450K dumps that could be stringed together for a longer time horizon analytics, or does that never happen in the real world? I don't think that you can do that with mission control. You can obviously have different recordings, but I don't think you could concatenate them in order to look at them over a longer time. I think that would, one, you can't do it, and two, I'm not sure of when that would actually be useful, because if you were taking different sections of time and trying to look at them in a single way, I'm not sure how useful that would be. I'm sure somebody will come up with a reason why you would want to do that, but that isn't possible in the way that mission control works at the moment. Is the event format in the JFC files a format specified by JDK 11 or Zulu? It seems very different than format used in Oracle JDK 1.8. No, this is definitely the binary format is the same for it's what came out of the Oracle JDK. There's no difference in terms of the binary format. So yeah, we use exactly the same format files that JDK 11 uses for the Oracle JDK, because remember, this was contributed to Oracle JDK 11. Now, if there is a difference between, no, there can't be a difference between JDK and JDK 11 in terms of the format. Reason I say that is because the two files I just showed you were taken from the Oracle JDK 8, and I loaded those into the mission control without any problem. So the format is exactly the same. And that seems to be it in terms of questions. So unless anybody else has got any questions, just give you a few seconds to see if anybody else can type quickly. Then I think what I will do is I will say that I hope everybody found this presentation useful, and that is the end of the webinar. Thank you. Oh, no, hang on, there's a question. Right, one more question. The compress option does not appear to be supported when starting JFR by JCommand. Why is this? Any plans to add the support later? Right, okay. I would need to check on that. Yeah, I'm not going to answer that directly here. What I will do is I will find out and I will tweet an answer to that, so that people can find out from the answer to that question, because I'm not 100% sure about that at the moment. Okay, so that is the end of the webinar. Thank you very much.